What is railroading in the United States? In engineering terms, the railroad is divided into three principal parts: track, signals and communications, and rolling stock. These play a crucial role, but the railroad's foundation is the very track it runs on.
You can't run trains without track, so it is critical you know the basics of track work. Track is the true foundation of the railroad, and is a more complex and involving system than its rather rudimentary appearance suggests.
The first key portion of any railroad track is the running rails. This is the only part of track work that contacts with the train, supporting its immense weight while smoothly and safely guiding it to its destination.
However, firm and precise rail spacings are key, so the rails are placed on top of long rectangular objects called ties, which are also used to distribute the weight of the train.
To hold the rails to the ties, they are usually fitted on steel tie plates and held in place with metal spikes.
To prevent longitudinal, and to a lesser extent lateral, movement, the rails are fitted with W-shaped metal rods called rail anchors.
To hold two separate pieces of rail together, two methods are used. The first method is simply welding the rail together. The second method is bolting the rails together using pieces of metal called joint bar.
Underneath the structure is a layer of crushed aggregate called ballast, which is used for drainage, stability, and further weight distribution. A finer layer underneath called subballast connects the whole structure to the ground and further distributes the weight.
Overall, these different layers provide a stable, sturdy, and safe path for trains to traverse.
However, trains do need to pass each other, and many tracks need to be connected in yards, so a special piece of track work is required for this task, the turnout.
This track work allows trains to switch between the tracks and provide more operational choices to the railroads.
Key to railroad turnouts are movable points, thin blade-shaped pieces of rail, controlled mechanically, that are flexible enough to allow lateral movement.
These are, in turn, attached to a point loader for automatic switches or a point lever for manual switches to provide a means to switch directions.
To allow the train to smoothly run across the diverging set of rails, a metal piece called a frog is used to direct the wheels. Another notable piece of track work is one you may encounter on a frequent basis, and is often the source of consternation for many drivers, the grade crossing. This special piece of track work consists of a section of rails paved over with asphalt to allow cars to cross smoothly and quickly to minimize interference with trains. While some crossings are merely marked with a crossbuck, most are guarded by 4 automatic gates and flashing lights to both warn and prevent traffic from crossing during a train's passage. The control of these gates is not related to track work itself, but instead falls into a category of the railroad which is equally crucial to its operation: communications and signals.
Signals and communications ensure that trains move safely and efficiently. As we just learned, grade crossings are an aspect of signals that everyone is familiar with, but there's more here than just flashing lights and crossbucks. Signals are used along the tracks to communicate to the driver the state of the line ahead, and determines whether to continue forward, slow down, or come to a complete stop. Signals can also have secondary functionality besides indicating whether to slow down or stop. They can indicate speed limits or changes, indicate if the train is taking a diverging path, and even indicate if a movable bridge is open or closed. Signals are automatically synced to a centralized control center, which monitors the trains and sets turnouts to properly guide them to their destination. These signals are interlocked to the turnouts, precluding manual control of each individual signal from the center. Nowadays, signals are being computerized to allow fully autonomous operation requiring less human input. This will increase efficiency and safety of rail operations and prevent human error. To ensure safety, all critical systems have several layers of redundancy. The most recent example of computerization is a system called PTC. Formerly known as Positive Train Control, PTC systems are digital data link communication networks. It uses a combination of GPS, onboard computers, and control center computers. The information PTC provides can be displayed to the engineer using cab signals. All this information is displayed on a screen for the engineer to confirm while driving a locomotive. Speaking of locomotives, that is a form of rolling stock.
When someone mentions rolling stock, they're referring to the part of the railroad that actually moves, freight cars and locomotives. Both are vital to any freight railroad as they are the component that transports cargo. Despite the seemingly infinite variety of cars, there are only 5 basic types. Boxcars, used mainly for paper and pulp traffic. Tank cars, used for liquids like corn syrup and chlorine. Flat cars, used for large long loads like logs and pipes. Hopper cars, used for granular loads like grain and plastic pellets. And gondolas, for everything else that doesn't need special treatment. Within these 5 basic types exist several subtypes, such as well cars for containers, a subtype of the gondola, open hoppers for coal, rocks, and other non-weather sensitive loads, and auto racks for automobiles, one of the many subtypes of the flat car. This large variety allows the railroad to transport nearly everything. However, freight cars can't move on their own. They need a source of power to get them over long stretches of track. That's where the railroad locomotive comes into play. Locomotives are the movable railroad assets which were created to specifically move freight cars over the railroad quickly and efficiently. In the US, most freight locomotives are predominantly the diesel-electric type, with only a few exceptions in the last 50 years. Contrary to what most of the general populace thinks, the diesel prime mover does not drive the wheels directly by a mechanical transmission. Rather, it functions like a large power station. Power is created by a medium-speed diesel engine of varying horsepower and is used to drive either a generator or alternator. The electricity is then sent to either 4 or 6 AC or DC traction motors to rotate the axles. These motor and axle sets are mounted in pairs of 2 or 3 in assemblies called trucks, which both aid in transmission of power and provide a smoother ride than rigid axles. To allow the operator to control the train, a cab is provided and is equipped with a control stand with the requisite controls. Some newer cabs also provide acoustic suppression and other comforts. To allow greater flexibility, all modern freight locomotives can be connected via electrical cables. Being controlled by one operator, they can pull longer trains more efficiently without requiring additional crews. Locomotives come in varying sizes, horsepower ratings, and number of axles to fit several roles on the railroad, such as mainline hauling and yard operations. There are 2 major builders of locomotives currently, General Electric and Proctorsville, formerly known as EMD.
Track work, signals and communications, and rolling stock, while very different, each play a crucial role in the railroad as an interconnected system. Each one is relying on the other to function, and without one of these 3 components, the railroad is unable to operate. These subjects are covered more in depth in the Rail Transportation Engineering program here at Penn State Altoona. Hopefully this video provided a glimpse into the lively and complex railroad industry.